Greetings. I decided to talk about the three secant relationships, and I'm going to start with the two secant lines intersecting on the circle, because that'll help us demonstrate the relationships of the following two. Here we have two secant lines that intersected on the circle, and we're given our formula, which is 1/2 the measure of arc CD. But we can also think of this as 1/2 the measure of our central angle O. And I'm gonna use this fact to demonstrate why this is true. On the right hand side we have the same image, but we have one of our secant lines going through the center, so therefore we have a diameter. And what I did next was I made this additional radius from point A to the center O to highlight our central angle, which is angle O, and I labeled that theta. And we know that a straight angle, in this case our diameter, will sum to 180 degrees. So if our central angle is labeled theta, then the remainder of it will be 180 degrees minus this angle theta. So that's how we get this. And then we also see that triangle COA is an isosceles triangle because two of its sides are congruent. So we can say these two base angles are also congruent, and I've labeled them as such. And then we use our knowledge of the sum of interior angles of a triangle to derive the formula for x. And that's what I've done down here. So we have our two base angles, x and x. We have our third angle, 180 degrees minus theta, and we know that sums to 180 degrees. We cancel out the 180, and then we solve for x, and we get x is equal to 1/2 theta, where theta is the measure of the central angle, and that correlates back here. And we'll use this fact to demonstrate the following two relationships. We're given the image on the left-hand side of the screen of two secant lines intersecting inside the circle, and we're given our formula. The important part to remember about this is we're adding the major and the minor arc. And a good way to remember that is these two secant lines, where they cross, it almost looks like a plus sign. So that's a good way to remember that when we're looking for the angle of two secant lines that intersect inside the circle, we're going to add the major and minor arcs. A more formal proof of this would be done on the right hand side, where I created a chord from B to D, creating triangle BXD, although I'm now regretting that I'm calling it BXD, but we'll move forward anyway. And from there, to find x, we can use our understanding of exterior angles and their relationship to the remote interior angles of a triangle. So we know that x is our exterior angle, so we say the measure of x is equal to the measure of our first interior angle, angle B, plus the measure of our second interior angle, angle D. But from looking at this image and from what we talked about in the previous slide, we know angle B is an inscribed angle subtended by CD. And we know angle D is also an inscribed angle subtended by AB. And using that, our knowledge of inscribed angles, we substitute our formula for inscribed angles for each angle, and then we sum them together, and that's how we determine the measure of angle X. Again, the best way to remember that we're summing is that it looks like a plus sign. Lastly, we have two secant lines that intersect outside the circle, and we're given the image on the left. Again, we're given the formula, and I want to point out that instead of adding the major and minor arcs, we're subtracting the minor arc from the major. Again, an easy way to remember that is this chord right here, BD, it looks like a minus sign. Inside the circle, it just looks like a minus sign. It doesn't look like a plus sign. It's a good way to remember it. A more formal way of understanding this is on the right-hand side, where we have triangle XBC. And I did that by creating a chord from B to C. And we know the measure of this angle B right here, the exterior portion of it, is equal to the two remote interior angles. So that would be angle C plus angle X. And then we just substitute in our formulas for inscribed angles, as we have here. But we know we want the measure of angle X. So we need to get the measure of angle C. I don't know why this is a 2. It should be a C. So we need to get the measure of angle C on the right hand side of the equation. So we subtract from both sides, and then we have the measure of X is equal to the major arc minus the minor arc. Another way to remember that we're subtracting the minor from the major is if we did it the other way, we would have a negative angle. And in this case, a negative angle doesn't make sense. So keeping in mind the order, i.e. major minus the minor, and knowing that the image will give us a kind of a clue as to whether or not we want to subtract or add, i.e. this looks like a minus sign while this looks like a plus, can be beneficial and can help students remember what we're subtracting, the order in which we're subtracting things, and whether or not we're adding or subtracting at all. Thank you for your time.